So I thought I'd take a look inside this IMAX dual power battery charger. I took it apart because I needed to repair some of the switches on the unit which had become a bit worn and damaged, and I was a little bit intrigued by what's inside it. Now I mainly use this for charging nickel metal hydrides and NiCad batteries, and I've found it to be quite reliable. But I've always been curious as to how safe this might be and how reliable the design is and whether there's any issues. So opening it up, I was always a bit wary of what type of power supply you might find inside it. You see so many videos of cheap Chinese dangerous power supplies inside it. I was a little bit nervous opening it up, but I can tell you that I was a little bit surprised. I possibly shouldn't have been, given that the big clover connector on the thing, but I was surprised that there was a full adapter in here, which when I've measured the leakage current to earth on there is negligible. So the output is safe to touch, and it does pass a 3000 volt insulation test as well, output to input. So that's good. So in terms of touching things and dying, it should be okay. Now there's lots of schematics for these floating around the internet. I think they're slightly older versions though. There are a couple of things that I was concerned about when I started measuring things on this. So this charger has a battery charger and a discharger built into it. Now the charger uses this little I think it's 0.1 of an ohm or half an ohm current sense resistor in there, which is pretty small given that it's a fast charge up to 6 amps or something. It must be 0.1 of an ohm or something. Anyway, so I normally use around 200 milliamps up to an amp, so I'm probably not pushing it that far. But this little fella here is partly a sense resistor for the discharge, but it's also it also does put quite a lot of the load on there as well. Now this thing is half an ohm. Now we have a discharge current, maximum discharge current on this device of 2 amps. 2 amps. So there is a possibility for 2 watts of power to be dissipated in this. So that's not good. In fact, it gets pretty hot. When you are running, I ran a discharge current test on this on the bench, and it started off discharging perfectly at 1 amp, but after a few seconds the current started creeping down. No surprise that this fella here is getting pretty hot. I suppose if you're doing this again, you might want to beef up the actual MOSFET that's actually doing the power dissipation, and maybe go with a lower current sense resistor in there and an amplifier to boost the signal up. There's a transistor under there, if you can see the little fella that's bolted to the plate. So this plate acts as a heatsink for a number of MOSFETs inside there, and that is actually doing the bulk of the dissipation. That actually regulates the discharge. Now the charge, I wasn't particularly happy about it. It's generally about 10% down. So when you think you're charging at an amp, you're charging at 900 milliamps. But there's a couple of points. 200 milliamps, for example. When you're charging at 200 milliamps, it's 27% low, which is a lot. So I don't know if there's some quantization errors coming in with the ADCs or something else funky going on. but there's a couple of points where it's miles out, and that isn't very good. I mean, if you're using this thing to measure the capacity of a battery and it's charging up and it thinks it's charging at 200 milliamps and it terminates the charge early, it's actually 20%, 27% down because it's been running at 20% low current. So that's not great. The entire current regulation for the charger is carried out by a microprocessor which ADCs the output volts and current. It's actually a little buck boost device that runs. There's two MOSFETs again underneath the board, and that is configured in. It's not a buck boost topology as such. It is a buck and boost combined, so it's not an inverting buck boost topology. It's still a fairly common topology, and it's pretty neat in that it saves you a few components, but it means that they are able to charge up to 20 volts out despite the fact that it's only 12 or 15 volts in or whatever it is. I think this thing you can supply from 11 to 18 volts, so you know it allows the unit to cover a much wider output voltage range. I must admit I've not used the balancing feature on there. It's just something I've not really needed, but for what it is, I mean, these things range in price from £40 to £50 on Amazon. I didn't pay that much for it. I think I got mine for about 25 quid. I don't know if it was an offer at the time or not, but I certainly wouldn't be wanting to pay £50 for this. I don't think it's worth it. The poor accuracy of the charge current is the thing that lets it down. I'm probably going to change this resistor value and tweak the unit to get that 10% back, but I suspect that I'm not going to be able to design out this 27% error at certain points. I think that might be a feature of the software. Maybe the unit isn't properly calibrated. I don't know if they map a different lookup table or something in there to the ADC value as part of a calibration process, or whether they just leave it as is and do nothing. One thing I will say is when you take this apart is just be careful with these little fellas here, because I took this apart to fix a couple of switches and ended up having to replace 3 switches because one of these had got stuck in. I thought that these just sort of pushed down and moved across, but they didn't. You'll have to pull these out of off the top of the switches, otherwise they just catch in and snap the top of the switches off. It's been fairly reliable. QC passed for you know. I mean, it's nice to see that logo. It's not a bad product. It's worth 20 quid, maybe 30 quid. It's not worth 50, 60 quid like you see some of them on Amazon. Incidentally, I think there are even more up-to-date versions now. So there are versions that's available with Wi-Fi. It'd be interesting to know if they are any better, if they've improved upon them, but it's not a bad unit, and for charging batteries it does a reasonable job. Just don't expect the accuracy. At the end of the day you get what you pay for, but I suppose from my point of view the main thing is it was actually safe, you know, so that's good. The voltage measurement on there isn't bad. It only has a 100 millivolt resolution, and I must say it's within 100 millivolts. Yeah, but that's not any great achievement, but at least it's not miles out. So yeah, that's it. That's my review. And if this was useful, please like my video. Thank you.